Find the value of c that will make f of x continuous for all real numbers. If no solution exists, enter d and e. We are given f of x equals the piecewise defined function, where f of x equals the quantity negative 16x squared minus 24x minus 5 divided by the quantity negative 4x minus 5 if x doesn't equal negative 5/4, and f of x equals c if x equals negative 5/4. We want to determine the value of c to make the piecewise function continuous everywhere. Let's begin by analyzing the rational function rule in more detail. Let's look at the function rule f of x equals the rational function. Let's begin by factoring negative 1 from the numerator and denominator. This gives us negative 1 times the quantity 16x squared plus 24x plus 5 divided by negative 1 times the quantity 4x plus 5. Let's see if we can factor 16x squared plus 24x plus 5. There are no other common factors other than 1 in the trinomial, and because the first term is 16x squared, let's use trial and error and try 4x and 4x in the first positions. Now we want to determine the factors of positive 5 so that the sum of the inner and outer products equal 24x. Let's try plus 5 and plus 1. Notice the inner product is 20x, the outer product is 4x, and the sum is 24x, and therefore the factors are correct. And now analyzing the rational function, notice we do have a common factor of 4x plus 5 between the numerator and denominator, and also notice 4x plus 5 is equal to 0 at x equals negative 5/4. This indicates if we were to graph f of x, there would be a hole at x equals negative 5/4. And if we simplify the rational function, negative 1 divided by negative 1 is 1. 4x plus 5 divided by itself is also 1. The simplified function looks exactly like the graph of f of x, except there would be no hole. So let's call the simplified function g of x. If we let g of x equal 4x plus 1, again the graph would look just like the graph of f of x, except there would be no hole at x equals negative 5/4, which means we can use g of x to determine what the value of c must be at x equals negative 5/4 to plug the hole in the function f of x to make the piecewise defined function always continuous. So now we'll determine g of negative 5/4, which is 4 times negative 5/4 plus 1. Simplifying, 4 divided by 4 simplifies to 1, giving us a function value of negative 5 plus 1, which equals negative 4. This indicates if we let f of x equal negative 4, if x equals negative 5/4, then the piecewise defined function would then always be continuous. So our final answer is c equals negative 4. Before we go though, let's take a look at this graphically. The blue graph on the right is the graph of the rational function. Notice there's a hole at x equals negative 5/4, which is why for the piecewise defined function, if you let f of x equal negative 4 at x equals negative 5/4, then we can see the hole is plugged and the function is continuous, making the piecewise defined function always continuous. I hope you found this helpful.